This training video will cover the installation and startup procedures for the Oscar LOWeFLOW system. We'll cover three things. We'll describe what an Oscar LOWeFLOW system is and how it works. We'll also show the installation procedures and also the startup steps to ensure that the system is installed properly and wired correctly. To start with, we have four main components to the standard Oscar LOWeFLOW system. We have a 1,500-gallon double compartment tank, as well as a single compartment 1,000-gallon tank, the Oscar disposal component, and then the low-flow basin. The Oscar, it's an acronym that stands for an on-site sand coil area recharge, and is simply a layer of sand with a predetermined manufactured coils on top, and then we cover the coils with another layer of sand. The Oscar is a proprietary technology with two main processes. One, it does treat or remove fecal coliform from the waste stream and is also a final disposal component for the waste stream. The Oscar has two main components. A coil. We have two versions of the coil, a 50-gallon a day coil as well as a 100-gallon a day coil, and then C33 sand. Again, a minimum layer of 6 inches under the coils, and we also cover it with at least another 6 inches on top. The standard 5-foot diameter coil is depicted here. The white PVC is just a bracket. It has nothing to do with the flow of sewage. It just holds the coil in the appropriate shape, and the green is just a background for contrast. Cross-sectional view of the Oscar. The red line, horizontal line, depicts the coil. The amount of sand is minimum of 6 inches under the coil on a prepared soil surface, and we cover the coil with another layer of sand. Now we use the Oscar system specifically again for bacterial treatment as well as a dispersal component, but specifically used with a low flow treatment unit. And the two technologies combined we refer to as the Oscar low flow system. After about 1 year of the Oscar being in use, you can see a lush green grass growth over the top where the coils are. This is just sand with the coils and low flow effluent being dosed to it. You can tell with as far as the green growth patterns are, the amount of nitrogen that's being taken up from the waste stream just in the grass growth. The low flow system will go through the components that comprise it. First, we'll start with the tanks. We have two tanks that have 4 tank functions: settling tank or septic, the recirculation component, clarification, as well as the dosing or discharge component. I'll illustrate with an expanded view of a 4,000 gallon a day low flow system here. The tanks will have a settling tank. We could refer to it as a septic tank as well. The recirc or mixing tank will have a clarifier as well as a dosing tank. The low flow filter itself is comprised of 3 components. We have a pre-manufactured coil, a media, and then a basin or a containment vessel to hold the low flow filter. Our typical arrangement for a low flow unit itself is a 500 gallon a day basin, a polyethylene rotomold basin with a coil installed, and we use a grow stone, which is an expanded glass, or it's like a pumice stone made from recycled glass. The system hydraulically works where we have raw sewage coming into our septic tank. We have, through positive displacement, the same amount of water or effluent will be dosed from the septic tank into the recirc or mixing tank. And at the same time that we have water coming in from the septic tank, we'll also have treated effluent coming from the low flow filter at about a 4-to-1 ratio. For each gallon of septic tank effluent that enters the mixing or recirc tank, we're going to recirculate that volume of liquid about 4 times through the low flow filter to achieve our recirc ratio. Imagine on the right we've got septic tank effluent that's being mixed with the effluent that's on the left, the low flow effluent. Again, imagine one part of septic tank effluent and four parts of the clear low flow effluent, and what you would have is what's in the middle in the recirc tank. So it's this weak dilute effluent that's actually being dosed to the low flow filter. So our pump will come on, pump effluent through our headworks, we'll pressurize the coils, and then as the liquid trickles down through the media, we get what we call attached growth, where the media is a contact area for organic material, bacteria, and water to adhere to, as well as having air gap in close proximity, so that we've got a very efficient aerobic environment that degrades effluent or degrades organic material quite rapidly. As that liquid then trickles down through the media, it's collected in the underdrain and then flows right back into the recirc tank. Now, as water enters this recirc tank from the septic tank, it's going to rise the level and it will seat a splitter valve, or it's kind of a foot valve that precludes that recirculated treated water from the low flow going into the recirc tank and forces the water to flow forward into our clarifier. From there, it will flow into the discharge tank and then go to the Oscars. Now, the standard single family resident recirc septic tank is comprised of a two compartment 1,500 gallon tank with a flow through port between the two compartments at about 24 inches off the floor. We'll have a pump on the recirc side with two floats. The pump does not have a shroud or any screening around it, and again, it's just the two floats. The liquid level is determined by the splitter valve, and what amounts to is the liquid level is maintained at about 1,200 gallons in this tank, and will give us about an 800 gallon recirc minimum liquid volume and a 400 gallon recirc volume. The clarifier tank is a single compartment 1,000 gallon tank. Our floats are going to be set at least as high as the pump, if not a little higher. We only need a 4-inch separation between the two floats. The liquid level below the bottom float is going to be considered the clarifier or clarification zone. The liquid level above that, or the working volume above that, is just that, our working volume. Note that a high level alarm in this discharge tank will electronically override off the recirc tank, so we'll get no more flow into this tank. So all of our emergency storage will be calculated inside the 1,500 gallon tank and not here in the 1,000 gallon tank. After we have the two tanks, the next major component is the low flow filter. There are four basic components to that, to the low flow basin and coil. One is the poly basin itself, the low flow coil pre-manufactured. We also have some miscellaneous fittings and plumbing that come with the unit. And the media is we call synthetic media made out of recycled glass, referred to as growstone. The basin and coil are on the far right, and we also have a new component that we add with that, and that is the foot. The foot is actually installed underneath the basin and gives the bottom a convex shape that allows all the liquid to, as it trickles down through the media, to flow to the outer edges, where it's then trapped within or funneled into what we call the channel on the lower outside rib. When you put all the components together, you'll notice the house on the bottom right hand side of the screen, where we have two tanks. On the right is the 1,500 gallon septic tank. Recirc tank. Moving left, we have the discharge clarifier, and then the round white circle represents the low flow treatment unit. And then to the left of the tree in the backyard, it's kind of hard to see because of the contrast, but we have 8 50 gallon a day Oscar coils, making a 360 gallon or a 3-bedroom design flow in a very small footprint. You can see the lot is just about the size of the screen, so we don't have a lot of room to work with, but we actually have a conforming repair with a drain field and reserve for this property under repair. Now, how to install the system? We're going to start with the Oscar. It's very simple. There are 6 basic steps to putting the Oscar system in. First, we're going to stake out the basal area. We're going to remove any excess organic material. Then we're going to do a preparation to the base before we put the soil on or sand on. We'll apply the sand, smooth that out to its proper shape, place the coils, connect the plumbing, and then cover that with the final cover sand. First, we want to stake out the basal area. If we're on some kind of a slope, we'll want to stake out the top edge along the contour. Most systems are going to be just a straight rectangle, right along the contour. Sometimes, though, we have a curved contour, and so we've got to do a little bit more in staking. It may take 3 or 4 or more stakes along the upper contour to establish that contour line. You'll notice on this design here, we've got a horseshoe-shaped Oscar system in the middle of the yard. It has a kind of a high spot, and so we've established the upper 2 corners, and then using the laser level, we'll just follow along the contour and stake, again, 2 or 3 more places to establish that curve. From there, we establish the bottom corners and the lower radius, and then we're ready to do our basal prep. Now, the basal prep, prior to that, we want to remove any organic material. If we're in a lawn or pasture area that has high grass, we want to mow that down, remove the grass clippings. We're going to leave the sod in the ground. If we're in a forested area, we want to take off all the leaf mat or leaf duff and get down to the mineral original soil, and then we'll start our basal prep. The basal prep is quite simple. Regardless of what type of equipment that you operate, you'll just want to take the teeth and just insert them into the ground, maybe 2-3 inches max. Make one swipe along the contour. Whatever sod or material comes up when you or making this pass comes up, whatever is left in the ground, leave. Obviously, the material that's built up at the end of our scarification, we're going to remove that and cast that off to the side. In other applications where you'll notice here that they've actually excavated down to flatten the basal area. If you have enough soil, you can do this. It will lower the soil profile. Make sure that that's approvable either from your design criteria or at the local health before you make a field determination whether you want to remove soil prior to the basal prep. In any event, the basal prep itself is still very similar. You'll notice that this soil is very dry and crumbles very easily. Hardly any effort it takes to make these little furrows. And it looks like all you've done is just kind of mixed up the soil. But really, below the loose material, there is a structure, and there almost always is a slight structure. You'll have a groove with a mound along contour. And what this does is, as the water moves through the sand and starts to go into the receiving soil, if it has to move down slope, the liquid is going to be forced to actually go over, and think of it as a speed bump, and it will kind of retain the water a little longer and allow for better infiltration into that basal area, as opposed to just having a flat surface where it sheets off and maybe would expose at the bottom of the toe of the Oscar. Once we've completed the basal prep, we want to apply the sand. This can be done in any number of ways. If you have access and you can back the dump truck right up to the edge of the basal area, go ahead and just dump it out. Others will scoop it out with the excavator from the back of the dump truck. Depending upon the logistics, you may have to shuttle the sand in. Access is the big key here. Once you get the sand down on the basal area, you can drive tracked equipment to speed up the spreading process. Again, you'll need to ensure that you've got a minimum of 6 inches under the coils. Now, it's important to note that the spot that needs to be level, and this is where the coils will go, is just under the coils themselves. I'll refer to that here in a second again. Once we have a level spot, we're going to put the coils down. We'll have a manifold on either side. The coils and the blank tubing are connected together as per the design. All of these parts, the blank tubing, the coil, the couplings and the barbed fittings glued into the PV or threaded into the PVC fittings are provided in the standard kit. And you'll notice as we pan away to look down the row of coils here that the only part that's level is right where the coils are, and then the rest of it slopes off. We just have to have 6 inches deep all over the entire basal area. We may have slightly deeper amount of sand under the coils on a sloping site, but again, it's just going to be where the coils are. So when we do the backfill on this, it's just going to cover the coils itself. The rest of the basal area does not need any more additional sand. The headworks that we're going to use is a manual headworks. In its placement, it needs to be, it should be near the Oscar itself. We're gonna want to put this headworks in the ground. The temptation is to put the headworks on the surface of the ground and then backfill with sand. It's convenient and it's easy. The problem is the sand does not give us very much insulation in the wintertime. We have had some problems with headworks freezing, and they've only been though when we buried them in sand. And a lot of times though, a good portion of the box is sticking out from the top of the sand or from the surface of the sand. If logistically you're not able to bury the box in the ground and you have to set it on the soil or on the surface of the ground, we suggest backfilling around that headworks with soil a good 12 to 18 inches and then finishing the backfill with sand. But again, we want to have soil or native material around that box for insulation. So the cover material that we're going to use, the only thing that's required is C33. You can use some soil over the top if you do have it very thin, 2 maybe 3 inches, and have very low organics. We recommend covering the sand with a little straw, plant grass seed, or some other kind of ground cover. Vinca minor or periwinkle is a good option. Jute mat can be used. At all times, though, do not use any topsoil mix that you might get from any one of the topsoil companies. It has lots of organic material and is used primarily to plant grass because it holds moisture. The problem is it holds moisture, and so the wicking action of this organic material will hold water that has come from the Oscar, and it'll make it look like it's failed when it has not. So when we're through with the installation, it looks kind of barren, just gray sand, but it does not take long for the sand to grow grass whatsoever. When we just spread a little grass seed on there, put the system into use, this Oscar is a subsurface irrigated treatment system that'll grow grass quite readily. It'll take about 2 hours or less for two guys once they've done their first one to go through the entire process. It's a very quick and easy installation of a drain field. Now the low flow installation is going to take a little bit more. We're going to talk about the tanks, and there's a little bit more plumbing involved, and that'll be the next section here. We'll start with the tanks. We, at minimum, will be using a 1500 double compartment tank as well as a 1,000-gallon single compartment tank. And the easiest installation for these, if the lot will allow you to do it, is to do a side-by-side installation. What's nice about this is that the tanks can be at the exact same level. You don't have to worry about having one invert higher than the other from one tank to the other. The tanks can be, again, right next to each other. And it's important that that the backs of the tanks are also even. We'll show you in the next couple of illustrations. Once the tanks are in place, in our kit that we provide, we have some tank adapters. There's 2 of them. And we're going to install those tank adapters in the rubber boots. And what these do is basically change these 4-inch openings to 2-inch. So you'll notice that not only the tanks are installed side by side and at the same elevation, but the back edges of the tanks are even as well. This makes it very easy to do the plumbing if you install it this way. The first thing we do once we have our tank adapters installed is we're going to glue in our split flow T, which is a 2-inch by 1-inch T. And there's actually 2 2x1-inch T's in the kit. One of them will have a 2x1 bushing, which you see illustrated here. And we're going to glue that onto the tank adapter with that bushing at either a 10 o'clock or 2 o'clock position, depending upon which side of the 1,500 gallon tank our 1,000 gallon discharge tank is located. Now in this case, the discharge tank is on the left side, so we're going to put the split flow T at the 10 o'clock position. Once we have that in place, we're going to glue in an elbow, a 90, with a short stub in it. On our discharge tank, we're going to glue in the other 2x1T. In this case, it doesn't have a bushing on it, but it will face straight up at 12 o'clock. And then again, we're going to glue just a short little stub in there. We're going to measure from the original elbow at the recirc tank over to the stub for the discharge tank and cut a piece of 2-inch pipe that length, glue on an elbow, and then glue that elbow onto the previous elbow. So we have a double 90, what we call double 90 arrangement there at the recirc tank. And then our last connection will be the 90-degree elbow going into the discharge tank. At this point, the plumbing between the two tanks is complete, and we don't need to do anything else to attach the tanks. But now what we have is inside the recirc tank, we're going to have a 2-inch stub. It's about 8 inches long sticking in. We're going to glue in the U fitting, which is again in the kit itself. And you don't need to get this perfectly level, but you want to get it as plumb as possible so that that street L is pointing straight up. The next thing we're going to do is install the splitter valve on top of that U fitting. And it's important to note that the splitter valve and the U fitting are not glued together. This is a dry fit. In the kit, you'll have, as you can see in the left hand there, the splitter valve itself. It has a 4-inch shroud. It's about 15 inches long, and it has a T and an elbow glued on top. We call that the H fitting. From there, we'll have to glue the handle in place. And then once that glue is set up, we're going to dry fit that into the or onto the splitter valve, or excuse me, the splitter valve onto the U fitting. And again, this last connection here is not glued. We want to be able to remove the splitter valve for servicing. Next, we're going to cut a piece of 1-inch pipe. The length will be from the bottom of the tank to the top of our handle on the splitter valve. If you cut a piece of pipe a little longer, just mark it so that you have a reference from the bottom of the tank to the top of the splitter valve. We'll remove both from the tank. We're going to line up one end of that 1-inch pipe to the top of the splitter valve, the handle itself, and then we're going to mark where the floats go. The 4-inch shroud is marked with markings top float and bottom float. So just make a mark on your 1-inch pipe. And then the floats that come with the system are already attached to a float clip. And the screw itself is going to be attached or fixed at those marks. So here you have the floats are completely are accurately installed, and you haven't had to do any measuring or calculating whatsoever. Now the only thing you can do at this point to screw it up is to put the float tree in upside down, but it's very easy to check. Put the float tree in the tank. As long as the top float is at the same elevation as the top of the 4-inch splitter valve, and the bottom float is 8 inches below that or so, you've done it correctly. At this point, we're not going to attach the float tree to the riser yet. When we do attach the float tree to the riser, we're going to use a 1-inch orifice shield. It already has a screw installed in it, and we're just going to fix it to the riser about 3 or 4, maybe 5 inches below the top of the handle of the splitter valve. What that will allow us to do when we actually put in or attach the floats, the float tree is going to rest on the bottom of the tank. The float tree will attach to the bracket, and now we have a stub of pipe of about 3 or 4 inches where we can then wrap our float cords. There is no need for zip ties in this application. If you happen to be use an infiltrator or a Roth tank, you can go ahead and use the larger 4x2 tank adapters that we provide, but you will need to have a 5-inch hole saw to use the grommets that will be needed for this tank. Otherwise, you can use the smaller grommets that they provide for a 2-inch pipe. You will need a 2 3/4 inch hole saw, and then about a 1 foot long piece of 2-inch pipe. And then you'll want to insert it in the tank just far enough so that it makes sense on how to install the U-fitting. And then from there, the installation is just the same as if it was a concrete tank. Now, once we have the plumbing for the 2-inch plumbing for the tanks completed, and the interior parts of the tank done as well, we want to dig our excavation for the low flow basin. And it is critical here that the bottom of the basin must be at least 2 inches above the top of the tank adapter for the recirc tank. So here in this illustration, we can see the tank adapter for the 1,500-gallon tank is closest to us. The best way to do this is go ahead and put your laser level story pole on top of that 2-inch pipe as it comes out of the tank. Get yourself a reading, and then you're going to want to dig a shelf that's illustrated here on the left side that's 2 inches taller or higher in elevation in the soil than that 2-inch stub. Now, it doesn't matter if you're 2 or 3 feet away from the tanks like this installation, or you're 50 feet away. You need to have that minimum of 2-inch elevation difference between that tank adapter stub and the bottom of the basin, or what the excavation is for the basin. It can be higher, but it can't be any lower. So to install the low flow basin, when we're done, the basin will look like it does here, where we have a convex shape to the bottom of the basin. We're going to have a 3-inch ADS pipe that's going to run around the inside circumference of the basin. Our plumbing will come in near the bottom. Our supply and flush line will come in near the bottom and then go vertical up through the center. It'll be filled with media with our low flow coil on top, and then it'll also be covered with media. The steps to do that is we're going to use a basin and a foot. We dig an excavation, again, 2 inches, at least 2 inches higher than our tank adapter elevation. We'll put this foot on the ground and place the basin right on top of it. And what you'll notice inside is you will now have a very slight convex shape, or a dome shape inside the middle of the basin. Next, we want to install, we have 3 tank adapters, a 1.5 by 2 inch male adapter, and then 2 other specialty fittings that we provide in the kit. Use Teflon tape or pipe dope. Do not use any tools, just use hand strength to attach these adapters. And again, always go from the outside in. And you want to tighten these as far as you can by hand. It'll almost always seat, or there might be just a little bit of gap between the stop and the 2 fittings. And on the inside, you'll see that it's sticking through. We want to glue the plumbing that we've provided with the kit. There'll be 2 what I call internal plumbing pieces. And when you get these put in place, they're just kind of going to dangle there in the air, and that's fine. Just don't worry about doing any adjustments at this point. We do have a new version that we put together where the top pieces are going to look like this. We call them the arms, the horizontal pieces. They're 1-inch pipe that are about 12 inches long. They're dry fitted into the elbow, and the caps are dry fitted. And these are put in place so that when we put the grow stone or the media into the basin, we don't get any material in the plumbing. And so all you have to do is just leave these in the horizontal position as you see them here. And then the grow stone has a pour spout or a dump spout on the very bottom. And you want to place the media, what I call on the back side of the basin, not directly on top of the plumbing, but just let it run on the floor and let gravity take over, and just let it backfill around the tubing or the piping itself. The first bag will fulfill the tank about maybe 2/3 full. Just dump it out completely, level off roughly. The second bag we're going to have to do in lifts, where we're going to fill this basin to the bottom of the top rib, and we'll have to get that fairly level. And what it'll look like when we're done is, again, it'll just be backfilled to the very top of the bottom of the top rib. And we want to try keeping any growth stone out of the top rib for right now. We're going to have to remove the arms, the dry fitted arms out of the plumbing. We're going to put the bracket on top, and then we'll have to glue in the arms to the internal plumbing and then into the manifolds. Now you'll notice on these, we zip tie the manifolds to the bracket. They do not have to stay zip tied when you do the installation. You can cut the zip ties off. Be careful not to disturb any of the tubing or slice it with a knife. And they can kind of come out at slight angles, but you should be able to glue your arms straight into your elbows and then into the manifolds, and everything will just kind of lay real flat right on top of the tubing like this. Once the plumbing is glued and connected, we're going to want to fill in the gaps with some more grow stone, and just cover all the tubing with a shallow layer of grow stone. Once we've got the coil completely covered, we're going to put the childproof mesh over the top. And you'll notice that we don't have any aggregates now in the upper rib yet, because what we're going to do is tuck this childproof mesh into the upper rib. And this is just meant to keep inadvertent access to a minimum. If a child wants to play on top of this thing and move some gravel around, they'll only be able to go down to the mesh. They won't be able to physically touch the tubing. Although if we do need to get into the unit, the aggregate can be taken off and this mesh removed and replaced after any repairs or things are taken care of. So once the mesh is installed, we'll put a little bit more aggregate over the top, and it will be important that you kind of hand pack the aggregates into the upper rib here to compact that mesh down. And this aggregate will settle in. We've got these square ribs, and over the next week or two or three, this media will settle a little bit. So we want to make sure that we mound up extra media on top so that it's just there on site in case, it'll always stay covered. And so when we're done, the unit looks, basically like this. The grow stone, the media, again, it's recycled glass that's heated, air is injected to it, and they create a pumice stone. Once it cools, it creates a pumice stone. It has about an 87% void volume. The aggregate itself actually has pores that go all the way through, so we will get not only treatment on the surface of the media, but also in the internal portions of the media as well. Much better than just a standard rock type media. Now, when we do the plumbing, it's important to note that when these basins are made, there's three ribs. The top two ribs are the outside edges are pretty plump, straight up and down. The bottom rib, because the way it cools, it kind of tilts in just a little bit. So when they weld in our fittings for our tank adapters, that very bottom fitting is actually pointed up ever so slightly. So it's important that the first, we have a very short piece of pipe, maybe even use a street L, but come out with the first fitting being an elbow. So if you rotate the basin 90 degrees toward the direction that you want that under drain to come, put an elbow on there, and then that way you won't have any tension on that fitting, and you'll have the right angle coming out of the tank. From the other angles, here's what it looks like. Also, our 1-inch plumbing for our supply and flush line, Because they're coming out in a sense square to the basin, and the basin being curved, they don't come out at right angles. So we strongly suggest that you use not 45s but 90s, where the first fitting either goes down or up depending upon logistics, and then a second 90 is installed so that now you can correct the angle, and now everything is going to be square in the trenches. You can see we've done the same thing on the left picture coming out of our headworks, where we'll elbow down to the trench bottom so that the piping is actually resting on somewhat bearing soil, so that when we do backfill, we don't have pipes suspended in midair. If for some reason you have to come straight out of the basin to get down to the tanks, use not just one elbow but use two elbows. Again, the first elbow will go horizontal, the next elbow will adjust for the angle of going down slope down the trench. So now that we've got the tanks installed, the low flow installed, we now start to do some of the major plumbing, and the headworks is the next major portion. We used to make two versions of the headworks, one for cold weather, eastern Washington, the other one for non-cold weather, western Washington. But instead what we've done is we make a universal uh, 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 gut package, for lack of a better term, where on the far right hand corner near gauge 1 we have a T that's open, and we're going to either install a cold weather adapter there, or we're going to cap that uh, end off. And inside the kit, you're going to have either on the left what we call the cold weather adapter, or just our cap or plug. The cold weather adapter has a small diaphragm in there that when the pump turns on and pressurizes, it seals up that small hole, and then when the pump shuts off and the pressure is released, that diaphragm then relaxes again and allows a small amount of water to leave that between doses. And so what that'll do is that'll preclude the water, if it does freeze, from expanding beyond the capability of the plumbing. At least half of the headworks, internal part of the headworks, will drain between doses. So even if it would to freeze, it won't break any of the pipes. So here we're showing our the non-cold weather application. We're going ahead and glue in the cap first. And then you'll notice on the headworks we have 4 other openings or connections labeled A, B, C, and D. And then in the kit we also have tail pieces that are labeled A, B, C, and D. And here we're showing the cold weather. And you'll notice that there are 2 B's, because those B's actually go to the same place. So you'll notice on the tail pieces, not only are they labeled A, B, and C, but they're also labeled where those pieces are connecting to. The A goes to the coil, B or C comes from the coil, and those will attach to those 2 tank adapters that we've already installed. And then B is going to go back to the inlet of the septic tank. So what will happen is you'll glue those 3 tail pieces in, and our valve box has already been pre-drilled. You'll turn it over, slide the plumbing into the holes, and then we're going to glue the last piece in, which is D. And when you turn this unit over, now we have instructions on the outside of where to connect the plumbing to. And going back to the previous slide, you can see the Headworks has the 3 outlets. One's to the coil, one's from the coil, and again they go back and they attach to the tank adapters. And the middle one, which is B, that's going to come around and go back to the inlet of the tank. And that's the flush line, or we call it the vent line, for all the flush water for the system will come back into the inlet of the tank. And again, this is only for the low flow portion of the system. We haven't now, if you have a situation where the risers are going to be taller than 12 inches, what you'll want to do is cut a supplemental riser, the difference between the riser height and the valve box. In this case, our riser heights are 18 inches, so we cut a piece of riser pipe 6 inches tall. We've placed it on the tanks where we want to put the Headworks, filled the riser with soil, packed it down, so now it is an anchor, and then we'll go ahead and screw the Headworks right to the riser. So now it won't move whatsoever. This makes it easy in backfilling so you don't have stuff moving around on you. Now, if we're going to do the cold weather with the reverse flush Headworks, it's the same procedure. We're going to glue everything on the one end, A, B, C, and again B. Remember always in Eastern Washington, put the cold weather adapter in. System won't function without it. Again, we put that in the Headworks, and then we glue in D last. Now, when we turn it over, again, we have the same instructions on the outlet side. In this case, we want to give ourselves a little bit of room to do some plumbing, so we suggest cutting a couple pieces of 1-inch pipe, placing them on the tank, and then putting the Headworks on the pipe. Unfortunately, if you just do this, the Headworks is going to want to roll around. So put a little bit of soil or some aggregates around those support pipes in the bottom so that they won't roll. And then in the kit, we're going to have the two tail pieces that are labeled to tank. They're going to be connected together this way. We've got a couple of street L's, an elbow and elbow and a T, and then it'll go off to the. In this case, we're going off to the left, and that'll be hooked into our 4x1-inch T on the sewer stub coming into the septic tank. Our other two ports sticking out there, again, those are going to go to our low flow basin. This is an aerial photograph of how we would suggest putting the Headworks in place. This is an infiltrator tank. We're looking down in the recirc tank. We come out at a 90-degree angle with our pump line, elbow over, go plumb in our flow meter, and then elbow again into our Headworks. And what this does is it gives us a real symmetrical, clean-looking installation where we'll have two tank openings with our Headworks in between, and the flow meter is between the pump and the Headworks. And this will allow us to measure, if we need to or want to, the flow, no matter what kind of function that we're providing or testing for. And then you'll see our to and from lines going to the low flow head off to the right, and our two tank line is heading off to the left. If we're doing the cold weather application, there are all of our drawings on the concrete tanks now show this illustration. We do provide a 4-inch by 1-inch T that will go just outside the inlet to the septic tank, and that's where we're going to plumb in the 1-inch line from the Headworks labeled to tank. We've pretty well done the installation. We've got all the plumbing done. The next part we want to do after the electrical is done is the startup. And here we're going to ensure that the wiring for the floats, pumps, and valves are done correctly. And we're also going to measure the pressures and flows. Now, we could use the wiring diagrams and trace the wires and use a lot of equipment to do electrical tests, but we're going to show you how to do just a functional test to be able to determine whether the wiring is done correctly, if not, where it's wrong, and then also if the plumbing is done correctly, or if we don't have an issue with either a broke line or plug someplace. So the first thing we want to do, again, proper wiring connections inside the control panel. Then we're also going to look at the proper float positioning in the tank itself. And then to make sure that the wire's been connected to the control panel are correct, we're going to do functional tests. So the first thing we want to look at is the control panel. You don't necessarily have to know the wiring diagram sequences. What is important to know is when you first look at the control panel before you turn the power on, look at the bus terminal and make sure that you've got a wire in every single position that's in here. It's very important. If there's wires missing, you might want to make a call. There's some reasons potentially that some wires could be missing. If a wire is missing, it may be now something was just left out, and we need to identify that. But real briefly, the bus terminal is divided into 3 sections using the yellow dividers to divide those sections. On the far left, they're numbered 1 through 8. Those where all the float wires are going to be wired. Between the yellow connections, they're labeled V1, V1, V2, V3, and VN. That's where our solenoid valves will be wired to. And then everything to the right of the yellow tab will be our pump wires, as well as the incoming for the power for the entire panel. So we'll start with the floats first. One of the questions comes up, especially with electricians, is, well, which pump is which? Or which floats are going where? Well, the recirc tank is, you can tell once it's installed by, there's three components in the recirc tank. One is going to be a pump, and that's the pump line with the yellow cord. You'll have the splitter valve, which is the apparatus right in the middle of the riser, and off to the right is our float tree. So the recirc tank is going to have those three components in there. The discharge tank will only have two. It'll have a pump and it'll have a set of floats, but it will not have a splitter valve. So now you know which tank is which. So when you start to do the float checks, you know what you're looking for. On the inside door of the control panel, there's going to be supplemental wiring diagrams that actually shows the floats and where they would be wired into the positions in the control panel. And then also along the bottom, it'll be listed inputs 1, 2, 3, and 4, and we'll show you what that looks like on the control screen. But all the information there to know where the wires should be and how to identify them within the control panel is listed here on the sticker. So if the electricians lose the wiring diagrams, no problem. You'll be able to identify what's happening here. So it's also, before we check the floats, we're going to want to find the screen inside the controller that has the large capital I in the left-hand corner. This is our input screen. And our floats have inputs that are numbered number 1, number 2, or for the recirc floats, number 1 being the bottom, number 2 being the top. And then we follow that same sequence for the Oscar. We have the bottom float number 3, which is odd, and number 4, which is an even number top. So both both floats follow the same arrangement. Odd is on the bottom, even's on the top. So now that we've checked the wires, we're going to power up the system. We flip on the circuit breaker for the controls, and we'll notice on the solenoid, or on the logo here, the yellow light, orange light will come on, and then once it goes green, we know we've got good power. And the first screen that will appear is our pump 1 cycles and pump 1 runtime. This is its lap meter and dose counter. We're going to use the down arrow and go down 4 or 5 spaces to the date and time screen. And then from there, we'll want to use the left arrow to go over a number of spaces. And this is where we're going to find our input screen. Again, it's the single capital I in the upper left corner. And here we see we've got the number 1 input and the number 3 input are illumined, which are backlit, which means the bottom float, if they wired it correctly, the back float for the recirc is up, and the bottom float for the discharge or Oscar tank is up as well. We should always see, when the system is in operation, we should always see the number 1 backlit. We never want to have the liquid level go below the bottom float on the discharge side. On the Oscar side, we will see time to time number 3 not backlit, because it will just time itself out. The float will drop, and then the time sequence will stop and wait. Number 2 input is going to be the high level for the recirc, and number 4 is the input for the discharge tank. Now it's important to use this input-output screen to check the floats, because if they wire the floats incorrectly, in other words, if they wire the high-level alarm for the discharge into the position for the discharge high level, and we get a high level in the recirc tank, the panel thinks the discharge tank has a high level in it. And what the panel is set up to do is, if we have a high level condition in the discharge tank, the recirc pump will not come on. All our emergency storage is in the recirc tank. If we have high flows coming in the recirc tank and we get a high level condition, the last thing we want to have happen is that pump to shut off. So we got to make sure that when we do these tests by lifting the floats and seeing which input indicators light, that they're in the right positions. Okay. So now that we've tested both floats, both sets of floats, we want to make sure that they're physically in the proper positions. Again, it's just a visual look. We put the float trees back in the tank. The top float should be even with the top of the splitter valve, and the bottom float should be below that, a good 6 to 8 inches. It can be lower, won't be a problem, but you don't want to have that bottom float any higher than about 8 inches from the top float. In the clarifying tank, the floats should be set, and there's really two criteria that you need to meet or be within. The bottom float can't be any lower than the top of the pump, and the top float can't be any higher than the inlet to the tank. And the floats need to be about 4 inches apart. So what that means is if you've got a high water condition and you're concerned about tanks flooding, you can actually raise these floats up, again, keeping them 4 inches apart, up to the point where the top float is just under the invert for the inlet of the tank. And that will maintain a large volume of water in the tank for ballast. Having more volume in the tank is actually a better thing. Again, we don't need emergency storage in this tank because a high level here will shut off the recirc pump, and our emergency storage will be accumulating in the 1,500 gallon tank. Now that we know that the floats are wired correctly and that they're in the proper positions, now we need to test the reverse flush headworks to make sure that the wiring here is done correctly. Now, we're going to use just functional tests to do this. In the control panel are 5 toggle switches. The top toggle switch number 1 is for the recirc pump. Number 3 pump is the discharge pump. Valves 1 and 2 always work together, so there's one switch for those floats or those valves. Valves 3 and 4 always work together, so there's again only one switch for that. And valve 5 is kind of the outlier, and it has its own switch. What we want to do when we're going to start this test is turn all the toggle switches in the off position. What that will do is that will preclude the controller from turning things on and off when we're trying to diagnose and make sure things are working. It'll just won't. It'll reduce confusion. So all the toggle switches are in the off position. And I got to give a little bit of explanation of what we're going to do and why. The Headworks has a 3/4 inch disc filter, and this is just for using one basin, one low flow basin. The Headworks will have a 3/4 inch disc filter. It's 120 mesh. There are 5 solenoid valves within the Headworks, and they're all normally closed valves. And you'll have 3 pressure gauges to measure pressures at 3 different positions. Now these solenoid valves, they are not irrigation valves. They are made to be to be used in a sewage application. And again, the valves are normally closed, which means in order for water to flow through the valve, you have to have both 24 volts of power to the solenoid and at least 15 psi to get the valve to open. Once it's open, actually I think it's 8 psi, but in any event, you have to have a minimum psi to open up those valves. The sequencing, what's going to happen is there's really what we call 3 valve functions, and I labeled them V1, V2, and V3. V1 is our dose to the low flow, and it's preset already from the factory, 33 minutes and 30 seconds off and 30 seconds on. And that'll just happen, back and forth, on, off, 90 times. The 91st time, it'll go to the V2 function, which will back flush the disc filter. It'll be a short 30-second rest, and it'll come on for 15 seconds, back flush that disc filter, and then we'll go to the V3 function. It'll start with the 30-second rest, and then the pump will come on for 2 minutes and flush the coil. Once the low flow coil has been flushed, then we go back to our V1 functions, and it'll dose 90 more times. With a 4-minute cycle, 90 doses will equals 6 hours. So this sequence happens 4 times a day, 24 hours a day, every day. and that keeps that disc filter and the tubing and the low flow clean. So what we want to do by checking the valve wiring, again, we're not going to trace the wires, but we're going to do functional tests. And again, the wires would be in the between the two yellow dividers. And if you did want to look at and understand how the wiring works, each solenoid, which is represented by the circle with S1 and S2 and so forth written in it, each solenoid has two wires connected to it. We take one wire from each solenoid, tie it together, and then that one wire goes back to our VN position. Think of it as kind of the common or the neutral for all of the solenoids. Solenoids 1 and 2 work together, so we're going to tie those two other leads together, and that'll go to our V1, which is our dose function. 3 and 4 are our reverse flush valves. We tie those two wires together, and that'll go to our V2 function or position. And of course, S5 is its own, so it's going to go to V3. Again, outlook of the Headworks. So when we want to manually turn on the Headworks and run it, we have to not only have the pump turned on, but we also have to have power to the valves. So we'll use the toggle switches, place the pump 1 recirc pump in manual, valves 1 and 2 in manual. And so what will happen with the Headworks is solenoids 1 and 2 will open the valves, the pump will turn on, and the flow path of the water will follow the green line. Solenoids 3, 4, and 5 aren't energized, so no water flows through them. So the flow and pressure will be as it's depicted here. And the only flow of water moving through the system is now through the coil of the low flow system. From here, what we'll be able to do is by looking at the pressures on the pressure gauges, we'll be able to tell whether the valves are working properly. What we should see is on gauges 1 and 2, they'll be virtually identical, and they'll be in the range of about 48 to 50 psi. Gauge 3 will be anywhere from 4 to 8 psi less than gauge 2. If there's a much larger differential between gauge 1 and 2 than 1 or maybe 2 psi, we probably have a bunch of debris plugged in that disc filter. If that's the case, shut the pump off, take the disc filter out, clean it, and then put it back in. And again, you should come up with these same pressures. If you don't, that means something's wrong, and you'll need to make a call or get a hold of somebody or figure it out yourself. Now there is a troubleshooting guide in the O&M manual that's posted on our website that will go through every single rendition of problem that you may have and tell you what you need to do to figure it out. Or call us and we'll walk you through it. Once we've got the pressures the way they're in the ranges that are adequate, on our flow meter, we should measure the flow, and it should be at right about 5.5 gallons a minute. It's not uncommon for the flow to be at 5.3, 5.4, and occasionally we'll see some higher flows at up to 6 gallons a minute, but no higher. If we see higher flows than 6 gallons a minute, we probably either have a fitting that's loose, there may be the tubing may have been damaged and it has a slit or a failure or break in it, and so our flow rate will be much higher. If it's much lower than 5.3, 5.2, we could have a blockage somewhere where not all the emitters are being used, as an example. Again, we're going to measure the flow at 5.5 gallons a minute. And we use this particular NetFM style flow meter, and we'll show you how you actually read it. It's a little bit different than most meters that you're used to. There are, with the 3/4 inch meter, there are two black background numbers. The first number that's with a black background is 100s. In this case, it'd be 200. So the next one is 10s, or so it's be 20. And then the 0 that's painted on the face of the meter is our single digits. And for that, we're going to read off of the first dial with the red dial on it. Each digit on this one is 1 gallon. So a full rotation of the dial on the right will be 10 gallons. Now the dial in the middle is tenths of gallons, and each rotation on here is going to be 1 full gallon. So if we were to actually record what this meter is showing us right now, it would be 220.64 gallons. Again, the middle dial, each rotation is as a gallon. So to figure out what the flow rate, we'll turn the system on, wait for the pressure gauges to become fully pressurized. Once they're pressurized, then we'll just count the rotations on the middle dial in 1 minute, and that will equate to our gallons per minute flow in our coil. Again, acceptable ranges are 5.3 up to 6, but we should be right about 5.5 the vast majority of the time. The next function, our V2 function, or our disc filter flush, we're going to reverse the flow through the disc filter. Our normal flow when we're dosing the coil, the water will enter the filter housing, flow from the outside of the discs to the inside, and then flow to our tubing. We're going to reverse the flow. We're going to put water on the inside of the discs, separate the discs slightly, blast water, reverse the flow through it, and dislodge a vast majority of the material that's accumulated on the inside of the discs. To do that, we're going to have the recirc pump on manual. We're going to turn off valves 1 and 2, and now we're going to turn on valves 3 and 4. And so that'll open, again, valves 3 and 4. The flow path of the water will follow the yellow line. And in this case, we're going the opposite direction through the filter. And the water is going to leave the headworks through what we call the vent line, which is to the two-tank connection. And we know that these valves are wired correctly when we get these pressures. Because we've reversed the flow now, we're going to have higher pressure on gauge 2 than we do in gauge 1, and it's usually about 20 psi to 10 psi, or about a 2-to-1 ratio. Sometimes it'll be 18 on gauge 2 and 12 on gauge 1, but you get the idea. It's going to be higher on gauge 2 than gauge 1, and it should be 0 on gauge 3. We're not concerned about the flow, although one observation is to look on the inlet of the septic tank, and we should see a very rapid flow of water coming in, roughly about 28 gallons a minute. Just about everything that pump can produce is moving through the system at this point. A normal functioning system will have a disc filter that looks like this. This looks really bad. It looks like it's clogged and no liquid would go through it. This filter was actually taken out of one of the systems that we tested at NSF, and this has been running for close to 8 months, and it still has the exact same flow and pressure characteristics as it did the day it was started with a brand new clean disc filter. You'll notice the red discs that are apparent on portions of this. That's where most of the water is getting back flushed through, and it's cleaning the internal portions of the filter, not so much the external part. If you were to open the filter up and you see this, probably wouldn't be a bad idea to clean it. On the other hand, if your pressures are what we've already shown you, that system's doing what it's supposed to do, and it's functioning as intended. Now, once we know that we've tested valves 1 and 2, 3 and 4, now we need to make sure that valve 5 is wired correctly. To do that, we're going to turn on pump 1, valves 1 and 2 again, 3 and 4 will be off, and we're going to turn on valve 5 to manual. And now the flow of water will be similar to our dose in that we're going to go through the filter, the forward flow will go to the coil, and now valve 5 will be open, so we're going to be relieving all the pressure and allowing the excess flow generated by the pump to scour the tubing, and then this flow will now go to the inlet of the septic tank. And the flow in the septic tank in relation to the backflushing of the filter will be about half the flow. We have lots of friction loss and we have some flow loss in the low flow coil, so we would expect to see a lower flow discharging into the tank with the coil flush. We know that valve 5 works when we have these general pressures. Gauges 1 and 2 will be about 40 psi. I've seen them as low as 35, as high as about 42, but they're usually almost identical. Gauge 3 is usually 0. Once in a while, the needle will bounce, so I'll say between 0 and 5 psi. Remember that gauge, that last valve 5 is open right there at gauge 3, so we're relieving all the pressure in the system, so we really shouldn't read anything. And we're not really concerned with the flow, just that we are having it come to the inlet of the septic tank. Now, the Oscar test is really pretty easy. We only have one toggle switch and there are no solenoid valves. So very easily what we're going to do is turn on pump number 3 to manual, and then we're going to go up to our Oscar Headworks. We're going to close the flush valve, that 1-inch ball valve that's in the box, and then we're going to wait till the pressure stabilizes. Now these gauges are labeled 1, 2, and 3 just like the reverse flush, and they measure pressure in the same locations. 1 is before the disc filter, 2 is after the disc filter, and 3 is after all the tubing. So once the pressures are stabilized, and all these pressures will be even, they should be within 1 psi of each other. It's a very small network in a single family resident Oscar system. Once the pressure stabilizes, then we're going to count the rotations again on that middle dial to know what our flow rate is. Once we've done that and completed the test, we're going to do a flush on the system where we're going to open the ball valve, again count the rotations or get our flow rate on the flush valve. And when we end the system, we want to when we finish this test, we want to make sure that that ball valve is closed, and we're going to turn the toggle switch for pump number 3 to the auto position. Our pressures should be about 50 psi all the way around on all these gauges. Now the flow rate when we're testing this with the valve closed is going to vary depending upon the number of coils we have in our Oscar system. Here you have to do a little bit of math. If you can't remember these numbers, it's best that you just record what the flows are so you know, and then either call somebody or give the numbers to the designer, and they'll be able to verify whether they're the right flows. In any event, each OS50 coil, or a 5-foot diameter coil, discharges at about 0.35 gallons a minute. So if you've got 10 coils in this system, you should have a flow rate of about 3.5 gallons a minute. Again, there'll be a little variation on that. A little lower, a little higher is not a problem. If it's much higher than that, like 4 gallons a minute, 4.5, 5 gallons a minute, you probably have a break someplace. Good news is it's going to be easy to find, even if you've backfilled the system, because the sand will get very wet and it'll surface virtually immediately. The OS 100, or the 7-foot coils, are twice the size, and so they'll have twice the flow rate at 0.7 gallons a minute. When we open that flush valve in the Headworks to do the flush test, we just want a minimum of 12 gallons a minute, or 12 rotations in a minute. More than likely, we're going to have between 14 and 18 gallons a minute. 12 is good, more is better. Again, record that. Once you're done, close the flush valve. If you want to verify, I can't remember or not comfortable doing the math, in the design manual as well as the operation and maintenance, and I think it's in the installation manual, you'll find this chart, and there's one both for the 5-foot coils and for the 7-foot coils that'll show you what the dose gallons per minute should be for each of the design flows. Now you've done the complete startup, all the floats, pumps, solenoids, valves. We know that they're wired correctly. If there was a problem, we've identified it, we've got them corrected, we've retested. So we know everything is done properly. We have our pressures and flows are recorded. All the toggle switches will need to be in the auto position, and all the circuit breakers are going to be on. And I would suggest doing this even if the house isn't going to be occupied right away. The worst thing that can happen, in my mind, at this point, we've done all this great work. The property owner has paid a lot of money to have the system in. We leave the system off, and then they move in. No one remembers to turn the system on, and now we flood the tanks, and we potentially have some other issues. So leave all the toggle switches in the up position, leave all the circuit breakers in the on, and also always remember to secure the tank lids. Now the question becomes, well, what do I record? What do I put on the as-built? At a minimum, these 5 lines need to be completed. For the Oscar, we want to have the pressures when we're dosing. Don't worry about the flushing pressures. That's not the issue. We want to know what the pressures are when we're dosing. So report all the pressures and label them. Gauge 1 pressure, gauge 2 pressure, and so forth. Then we also want to record what the flows were. We want to record the flow when the valve is closed. Again, we want to record the flow when the valve is open. Now the low flow, it's much simpler. All we want to do is we want to know what the pressures are when we were dosing, and we want to know what the flow rate when we were dosing. Once we have that information, we can always then refer back to that, and it's the best quality control check after the fact. Hopefully, we've answered more questions than we've created, but for any of those questions that you have, please, at this point, give us a call. We'll get your name on the certified list, and then we'll schedule for a first install training when you got your first install to train. And then we'll also make sure someone comes out and trains you on the startup procedures as well. Feel free to refer back to this video for future reference. Thanks for watching.